Hello, everyone. Welcome to section 4.4. In the last section, we talked about sort of the introduction to logarithmic functions. And in this section, we're going to be talking about the laws of logarithms. So without further ado, we're going to let a be some positive real number. And then just for stating the laws, we're also going to let a, b, and c be real numbers. And just for things to work out correctly, we're going to let a be greater than 0 and b be greater than 0. That way we can plug a and b into the logs. So the first law says this. If you have a log base a of a times b, you can rewrite this as log base a of a plus log base a of b. So multiplication inside the log becomes addition outside of it, and vice versa. And just to give you an intuition for like why this happens, this comes from the exponent rule, ax times a to the y. You can combine those and get a to the x plus y. So just to kind of give you a reason for like why it doesn't work the way you think it would, it comes from the exponent rules. Okay. 2 log base a of a divided by b, so kind of similar, is going to be log base a of big A minus log base A of b. And again, just to give you some intuition for like why this is true, this comes from the idea that if you have ax over a to the y, you can rewrite this as a to the x times a to the negative y, and then you can combine them to get a to the x minus y. Okay. The third and final law is you have log base a of a raised to the c power. You can take that c, that power c, and you can drop it down in front of the log, and you can write it like c times log base a of a. This one's a little more esoteric and mysterious. It ultimately comes from, I believe, the idea that if you take a to the x to the c, you can rewrite this as just a to the x times c. But that doesn't really give you terribly much intuition. It's just an esoteric fact. Okay, so these are the 3 laws of logarithms. They're all very useful and very important. So here's a warning. These are very common mistakes. Please don't make them. Ask nicely. So if you log base a of a over log base a of b, this is not log base a of a over b. Okay? You can't just move the log out. This is not true. Do not do this. Okay? The other common mistake is log base a of a plus b. This is not log base a of a plus log little a of b. Okay? So maybe I'll write it in red. These are wrong. Yeah, so be careful. These up here are good. These are correct. These are not. So just a heads up, this is pretty common errors. But let's go ahead and practice using the laws of logarithms with some actual numbers. So let's go ahead and say we wanted to simplify log base 2 of 60 minus log base 2 of 15. Right, looking at log base 2 of 60, like what power do you raise 2 to get 60? I don't know. I don't know what power you raise 2 to get 15. But we can use a law of logarithms, right? This is, you're subtracting 2 logarithms. So we can use law number 2 to write this as log base 2 of 60 divided by 15. Ah, I know what 60 divided by 15 is. That is just 4. Log base 2 of 4, that's going to be 2, right? Because 2 raised to the 2 power is 4. So look at that. We use the law of logarithms to simplify that. Okay, cool. Let's look at another example. What if we had 1/2 times the logarithm base 3 of 81? You could probably do this one without using the law of logs, but let's go ahead and use them anyway. I'm going to move that 1/2 up into the exponent of 81. So this becomes log base 3 of 81 to the 1/2 power. And the reason, and that's using law number 3. And the reason I did that is because the 1/2 power is just square root, and I know what the square root of 81 is. Square root of 81 is 9. Now, looking at log base 3 of 9, I can tell you that is 2, because 3 squared is 9. Okay, cool. All right, let's look at maybe a more complicated example. Let's say we wanted to simplify something like log base 2 of 6 minus log base 2 of 15 plus log base 2 of 20. Well, let's go ahead and combine that subtraction. So we get log base 2 of 6 over 15 plus log base 2 of 20. So that was using law number 2. And then I can combine the addition using law number 1. So this becomes log base 2 of 6 over 15 times 20. And then if you do some simplification, I think you get this log 2 of 8. And then I think we need to raise 2 to the 3rd power to get back 8. So this is going to be 3. 2 to the 3rd power is 8. So yeah. Okay, cool. Maybe let's look at just one more example, just for kicks and giggles. We wanted to do log base 6 of 36 to the 18th power, for example. We can drop that exponent down and we get 18 times log base 6 of 36. So log base 6 of 36, 36 is 6 times 6, it's 6 squared. So that is going to be 2. So we get 18 times 2. And then 18 times 6 again. Yeah. Very nice. Okay, so those are some examples of how we can use the law of logarithms. There's one more useful logarithm fact that is very nice. It's called the change of base formula. The change of base formula is if you have some log base b of x, we can rewrite that as log base a of x over log base, base a of b. Let me make this a little bit clearer. There we go. So this is for whatever a greater than 0 you want. Right? So this is useful because you can take a logarithm that has some base and some number, you don't know how to figure it out. But you're like, but I know that somehow I can, if I have a different base and I play around with the two numbers, I don't know how they relate, I know that there's a different base that'll make them easier to understand. And you could just pick that base and use the change of base formula to simplify things. So, for example, let's say I had log base 16 of 2. And what you can do is you can use the change of base formula. You can rewrite this as log base 4 of 2 over log base 4 of 16. Log base 4 of 2, 2 is 4 square rooted, so I think it's going to be 1/2 over, and then 4 times 4 is 16, so log base 4 of 16 is going to have to be 2. And so that's actually going to be 1/4. Okay. We could also look at something maybe even more wacky. We could do log base the square root of 5 of 125. This looks nasty, but we can use the change of base formula. 125 is going to be, it's 25 times 5, so it's 5 cubed. And square root of 5 has a 5 in it too. So what if we try to do the change of base formula? And let's do log base 5 of 125 over log base 5 of the square root of 5. This is more easy to understand. Let's see, I said 125 was 5 times 5 times 5, so 5 cubed. So log base 5 of 125 is going to be 3. And then log base 5 of the square root of 5, I think it's going to have to be 1/2. And then this simplifies down to just 6. Wow, so we use the change of base formula to simplify log base the square root of 5 of 125. That's pretty good. You could even go back the other way. And if we had something weird like, let's say log base 42.2 of 9 over log base 42.2 of 3. That's wacky. But notice that the logs have the same base, top and bottom, 42.2. So we can use the change of base formula kind of going the other way that we've been using it. And all we need to do is just write log base 3 of 9. Now you have to be careful that this only works when the bases of the logs match up, top and bottom. Okay, but log base 3 of 9, we know that. That's just going to be 2. All right, so there's some log laws for you and the change of base formula. These will be very useful when we move into the next section, which will be about solving logarithmic and exponential functions.